Somewhere in school, someone told you there's no such thing as the square root of -1. And then, a year later, someone else told you to use it anyway. They called it imaginary, worst name in all of mathematics. Because this number isn't imaginary. It's not even really a number. It's an instruction. It says, turn. And once you see that, a whole hidden layer of math clicks into place. Start with the number line. Every ordinary number lives on it, a position, left or right, of 0. Multiplying by a positive number stretches along that line. But watch what multiplying by -1 does. It takes 1 and sends it to -1. It flipped it to the other side. That's not stretching. That's a rotation, half a turn, 180 degrees. So here's the question that unlocks everything. If multiplying by -1 is half a turn, what's a quarter turn? A quarter turn lifts us off the line entirely, up into a second dimension. Call that step I. Multiply by I, and you rotate 90 degrees counterclockwise. Do it again. I times I, and you've made 2 quarter turns, a half turn, which lands you exactly on -1. So, I squared equals -1, not as a strange rule to memorize, but because 2 quarter turns make a half turn. I was never the square root of a paradox. It's just the number that lives 1 quarter turn away from 1. And now every piece we've built comes together. These numbers don't live on a line anymore. They live on a plane, a flat world where every point is a number and every number is a place. Multiplying doesn't just scale now. It scales and spins. The circle, the sine, the cosine, all of it becomes the natural language for describing where a number goes when you turn it. That's why complex numbers run through everything: electricity, waves, quantum physics. Anywhere something rotates or oscillates, these numbers are already the map. So, the square root of -1 was never impossible. We were just trapped on a line, when the answer lived on a plane. Give a number room to turn, and imaginary becomes the most concrete idea there is. The name was wrong. The number was always real, just pointing in a new direction. No more excuses. See you at the next theorem.